Hi Professor, welcome to my state machine project in EEE64. State machine is a very essential concept in sequential circuit, and today I use the state machine idea to work to apply on a mathematical concept. It's a Fibonacci sequence. The Fibonacci sequence is a very popular in mathematics, in which the third number is always equals the sum of the last two previous numbers. And here's my diagram. If I set the input equals 1 or input high, my number is going to go from 0 to 1, 1 plus 0 equal 1, 1 plus 1 equal 2, 3 plus 2 equal 2 plus 1 equal 3, 3 plus 2 equal 5, 5 plus 3 equal 8, 8 plus 5 equal 13, and so on. And in the other direction, when x equals 0, or the input is low, the sequence is going to go backward from the higher number to the smaller numbers. And here's my state diagram, and I use that to design my state machine. This is just a small sample state diagram because I don't have enough room to put all the cases, because Fibonacci sequence is an infinite sequence and there's no ending. So I start if this case is going backward, you see, which is descending. It goes from state 5 when it's equal 5 back to state 4 when it's equal 3, and we'll go back to state 3 and when it's equal just 2. And on the other direction, it's going extending. When the input is high, you go from state 5, state 6, and state 7, and the values go 5, 8, and 13 respectively. And I can combine these two diagrams in once, but to make it clear, I just separate it into different ones for the PowerPoint. And here is how I design my code. It's a sample for state 0. When s equals 0, when state equals 0, which means the value is equal to 0. So I have a 7-segment display, have 6 high inputs and 1 low input. So when it displays, it's gonna display the number 0. And then I use if-else statements. When the input is high, the sequence gonna move to the next state, which is state 1. Otherwise, it will, when the input is low, it will go backward, which means from 0 go to the highest number of the series. My series is start at 6 right here because I just work on 1 digit. And here's my demonstration. And then I go backward. You can see the number 1, it stays twice because it happens in the series. I got a problem at the beginning because I tried to use loop or for loop to make state run twice, but it actually didn't work. But then I just set another state with the same value for 1, and it worked really well and it's really clear to follow. And the problem why I was using only one digit, because the pin map obtaining from the the products is mainly F2. It shows only it provides only 1/7 second display, and I had no idea how to set to make these three light up so I can have uh, the higher values of my sequence. And another problem that um, I encountered in my project was from if it was just one digit, the way I did was just listing all the cases, all the possible cases from 0, 1, 1, 2, 3, 5, and 8, which is only 7 states. But then when we're thinking about making it, expanding it, which is a bigger number, there would be tons of cases because the number will never end because it just keep on adding up. And I was trying to use a math expression and use three variables I0, I1, I2 with I2 equal I0 plus I1, and then I obtain the decimal numbers, but I was not able to how to convert the decimal numbers into binary numbers and then input in the FPGA. In conclusion, state machine is a great tool and it's very crucial in logic design. Even though the Fibonacci sequence was just it's just a very simple program, but it shows how powerful and how flexible the FPGA, the state machine, is able to perform. And I'll try to figure out how to make the other three lights up, and then I can use it to expand to make it more broader, so the students and the math teachers can use that to demonstrate in class or use it to 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 understand the behavior of Fibonacci sequence, which is one of the most popular sequence in mathematics. Thank you for listening.